Here we're going to be talking about web application security testing. So before we get started, let me talk a little bit about ethics and making sure that when you're doing any sort of security testing or penetration testing or whatever you want to call it, security assessments, that anything you do is either on your own system, and in this case what we're going to be doing is working on a couple of virtual machines I have on my laptop. So having your own lab is a great thing. If you are working with somebody else, make sure that you have permission from the owner so that you don't get into trouble, because when we start talking about web application testing, there is a very real chance that you could do something like take the application down or take the website down, which means that if it's a business, suddenly their customers can't get to the website anymore, and that's a serious problem for them. Not to mention the fact that if you do something like that, it's very close to being, if not outright being, illegal, depending on what you do. And so be very careful about who you're doing this with. Make sure that you've got it in writing from somebody who really has the power to give you that control or that permission. So get it in writing, make sure that it's very clearly understood what it is you're doing, why you're doing it, and what the outcome is expected to be. So you're going to generate a report, you're going to tell them how to fix the problems. So make sure that you've got permission before you get started. Or, as I said, just work on your own lab systems in order to get better at what you're doing, and I certainly hope that you're going to be doing that and following along as we go through here. So we're going to be talking about web vulnerabilities. There are several of them. We'll talk about XML attacks and cross-site scripting and various injection attacks as well. We're going to talk about browser plugins that are going to help you as you are doing testing. There are a large number of browser plugins for different browsers, and we're going to look at plugins for Firefox and Chrome, so you can get plugins that will help you do the testing and do some of the work for you. And then we're also going to talk about just manual interactions in order to make sure that what you find is legitimate. So you've got some tools that are going to do some work for you. You want to do some manual testing to make sure that you don't have any false positives, meaning that the tool said, oh my gosh, I found this, and in reality it wasn't that. It got some sort of spurious response that made it think that there was a problem when really there wasn't. So how are we going to be doing this? Well, we're going to be doing it hands-on. We're not going to be just walking through slides explaining things. We're going to be doing it in context, so we're going to look at these different types of attacks and talk about how they work. And primarily this is as real world as we can get within this context here. So we're going to actually be doing these attacks against a couple of websites that I've got. So I hope you're ready to start doing some web application testing. So Kali Linux, like most Linux distributions, is reasonably lightweight in the sense that you can run it on a lot of different types of hardware, but there are some minimum system requirements. So we're going to talk a little bit about what you need to get going. First of all, if you're going to run it on hardware, and I'm going to end up running it on a virtual machine, but if you've got an old system around somewhere that you want to use, that's great, as long as it meets the minimum system requirements. The minimum system requirement is 20 gigabytes of hard disk space, so you need that in order to install the operating system. I will tell you that if you want to store any artifacts from what we're doing, you probably want to be in the 25 to 30 gig range or higher, depending on how much you feel like you're going to want to store. You need at least a gigabyte of memory. That's the minimum. 2 gigabytes or more is recommended, and obviously the more memory you install into your system or your virtual machine, the happier your operating system is going to be. It's going to run a little bit better, a little cleaner. You need something to boot from. You need a CD-ROM or a USB stick or something like that. In our case, again, we're going to be working from an ISO image that we're going to use to boot into. Now, another note is that Kali Linux will run on a Raspberry Pi, and if you're not familiar, a Raspberry Pi is a computer that's about $35, and it will actually fit into the palm of my hand, so it's a really small device. It will run Kali Linux. They have an image specifically for the Raspberry Pi. So if you want to do hardware but you don't want to spend a lot of money, you don't have anything, you can go get a Raspberry Pi. You still need, keyboard, mouse, and video, but the computer itself is really cheap and it runs Kali pretty well. So as I said, we're going to be doing a virtual install. So the first thing that you need is a hypervisor, and a hypervisor is a piece of software that sort of mediates between the operating system that you are running, which is the guest operating system, in our case that's Kali, and the host operating system, and in my case that's going to be Mac OS. So there are a number of hypervisors that are around. So VirtualBox is one that is from Oracle, and that one's free to use. VMware also is a pretty well-known hypervisor. And another one that runs on the Mac OS is Parallels. So the other thing about using a virtual install is that you want to make sure you've got enough memory. So you're probably comfortable with the amount of memory that you've got in your system, but the moment you add a hypervisor or another operating system, you have to take into account the needs for that. So for the amount of memory in your real hardware on a virtual install, you need to make sure that you've got enough to work in your operating system comfortably, plus the operating system that you're going to be running as a guest. So we've got a couple of different ways that we're going to install. You could do a hardware, you could do a virtual install. Either one is fine. At the end, you're going to have a Kali Linux distribution that you can use. And so we can get started on acquiring Kali, and we'll do that coming up. So a web application is really a number of systems that you could potentially be interacting with, and I've just got a page up here that's got a good representation of what you're typically going to run into when you're talking about a web application and the architecture that's associated with it. So on your end, you've got a client, and that's your browser. So that's really going to be where the application presents itself. So you're going to get the presentation in your browser. So on the other end, where the servers are, the first thing that you're going to run into is you're going to typically run into a web server, and that's going to take your requests in. So you're sending HTTP generally off to the web server, and it's consuming that HTTP and determining what to do with it. Now, behind the web server is an application server. So maybe it's a Java application server, or maybe it's a .NET server, and that's where the business logic lies. So all of the code that really tells the application what to do is on the application server. And then behind that is a database server, typically some sort of database server. Maybe it's XML storage, or maybe it's a SQL database. So we've got something that is going to store important information and maybe present the application server with a little bit of guidance as to what to show to the user in the client on the browser. So as we work through, we're going to be kind of talking about how to work with the different layers here, and you want to keep the layers in mind so that as you're thinking about the different attacks, thinking about what layer we're actually impacting when we do the testing that we're going to be doing. When we get started testing, you really probably want some sort of lab to work with, and particularly as you're learning some of these attacks, having a little bit of guidance to help you along is really helpful. And this is a start, but as you really kind of drill through and start working with these things, using something like WebGoat is useful, because what WebGoat does is it presents you with a number of web-based attacks and will help walk you through how to perform these attacks. So this is the WebGoat project. It's run by OWASP, which is responsible for not only this project and several other projects, but also maintaining a list of vulnerabilities and really focusing on getting web application security to much higher standards. So I've downloaded WebGoat and I've got it here in downloads, and what I'm going to do is I'm going to run it now. And we use Java to run this because it is a Java executable, but what we're going to end up doing is connecting to it through a web browser, just as you normally would. So this should be up and running at this point, and now I can just go to my local system and I'm going to go to port 8080 and WebGoat. So now we are at a login screen for WebGoat, and you can see that there are 2 accounts that are built in. That's at the bottom of the page. If you want to just be a user, which is what we're going to be, you're just going to log in as the user guest, and then the password is going to be guest. Now, as soon as we log in, you'll see on the left-hand side, these are the different types of vulnerabilities and attacks that you can run against web applications. And if we just bring something up here, so for example, authentication flaws, and I go to password strength. So there's a little bit of a lesson here. So the accounts of your web application are only as safe as the passwords and so on, and then it tells you this is something that you can do to test your understanding of password strength. And if you need help, you can show hints. So as I said, WebGoat will really help you through understanding these different types of attacks so that you can play with them in an application that is deliberately vulnerable. So there are a number of other applications that are deliberately vulnerable. There's the DVWA, which is the damn vulnerable web application, and then there's XVWA, and then there are several others. If you do a Google for vulnerable web application, you'll come up with some pages. OWASP has a page, for example, with known applications that were designed to be vulnerable for exactly this type of work, so that you are working to understand what these vulnerabilities look like and how to exploit them so that you can make your web applications harder so that attackers can't get in. So we're going to take a look at a particular class of application attacks called cross-site scripting attacks. So the idea behind cross-site scripting attacks are that I am creating a little script for someone else to run, and it's not necessarily that it's cross-site. What it really is that I am doing something and getting you to execute it on your system. So it's not like you're really crossing websites necessarily, although that is a possibility. So there are a couple of different kinds of cross-site scripting attacks, and let's talk about those. So I'm going to be using the Damn Vulnerable Web Application, or DVWA. This is something that you can download and install for yourself if you've got Metasploitable, or Metasploitable 2 anyway. This just comes installed. So this is one of the vulnerable applications that gets installed in the web server in Metasploitable. So we're going to go to cross-site scripting, and as I said, there are 2 types of cross-site scripting attacks. The first one is reflected, and what that means is that I am going to basically craft a URL, and I am going to create that URL, and I could put this on another site, which is one reason why it's called cross-site scripting. And then if I get you to go to that site and you click on the link without realizing exactly what it's doing, you're now running my script. Except that it's running basically from another system. So let's just play around with this right here. So I'm going to do a very simple one. And you can see that I'm really creating some HTML tags, because what's going to happen is when this gets rendered, it's going to be placed into the HTML, and when you come to hit it, it's going to run this script. And so that's the idea behind cross-site scripting, is I can create this script and then generate the URL basically, and you can see that what happened is I got an alert box, which was what I was telling it to do, was to generate an alert. And you can see in the URL, this is what it looks like. So it says name, and then it's got my script there. So now we have a way to run scripts in somebody else's system. So as I said, I could create this URL, dump it on my system, but it's going to execute over on this damn vulnerabilities website. So if you were, for example, working on somebody on a target who had access to a bank and they were logged in, they had a cookie to get logged in, you could do a cross-site scripting attack and maybe grab their data that was associated with that, or you could run a script to grab details or cookies from their site. So we've got a number of possibilities using these cross-site scripting attacks. So just very quickly, I can show you the stored one as well. Here is where we've got a guest book, and with the guest book, that is stored in the database. So anytime somebody comes off to this page, they're going to be displayed these messages that were stored in the guest book. So if I store some script information, so tags and a little bit of JavaScript there, that's going to be run on your system when you come to visit the site. So now I've just got this being persistent. Anytime somebody comes to this site, they're going to run the script, and whatever it is I was having it do, in the case of what we just did, was just popping up an alert box, which isn't very interesting, but there are a lot of other things that people can do with JavaScript. So that's going to run anytime somebody comes to visit the site. So we've got a couple of different types of cross-site scripting attacks. We've got reflected and stored, and you can use DVWA and practice different types of scripts using this vulnerable web application to get better at understanding how these cross-site scripting attacks work. Now, another common attack, and one that's actually really dangerous, is one that works with the database on the back end. So if you've got a SQL database on the back end, we've got a way to potentially impact that database. So when you think about the web application architecture, what we were impacting with cross-site scripting attacks is we're really impacting the client, because that's where the script is running. In the case of a SQL injection attack, what we are impacting is the database directly, because we're passing right through the web server and the application server, and ideally getting our own SQL code directly to the database. So we're going to take a look at some SQL injection here. And the idea behind this particular page is I want to get the database to provide all of the details that it's got about users. So this is something that you could do with, say, a login attack. Let's say that you've got a login form where the login information is stored in the SQL database. What is really happening on the back end is there's a select statement that is looking for the particular details that you provide. Normally, you would just get a single response back if you provide good information. If we were to do something like this, though, now suddenly we've got all of the details back, and what's going to happen is, even though I didn't provide a legitimate input, what the application is going to see is, hey, we've got some responses back, therefore this must be good. And what I did was I used this OR. So what the SQL is doing is it's saying where username equals and then the data that we've provided and password equals. And what I have inserted is an additional piece of logic that says OR, and then added something that is always going to be true. So in this case, I did A equals A. So A is always going to equal A. And if you think about how Boolean logic works, if I've got a false on the left-hand side and an OR and a true on the right-hand side, the entire expression is true. Therefore, every field is going to match what we've created there. So what we get back is all of the results from the database. So in a SQL injection attack, what you're doing is you are creating a SQL statement that will pass through the logic layer and get executed directly by the SQL database on the back end. So this was a pretty simple one. There are other ones where you could, for example, drop databases and drop tables. So you can do some pretty bad things using an SQL injection attack. This is just a very benign example of an SQL injection attack. So let's talk about command injections. And this is another injection attack where what's really happening is the application isn't paying enough attention to the data that is being sent in to whatever the back end is. So in some cases, the application needs to reach out to the operating system to do something in particular. And this is where we have the ability to insert or inject operating system commands. So again, we're going to be using DVWA for this, and I am going to go to command execution. So this is a ping form. All I need to do is provide an IP address here, and I can submit, and what I'll get back is the response from that ping. So that's just being fed off to the operating system, and then the response is coming back. So what I can do in the case of Linux, which is what I'm running on, I know that a semicolon is a command delimiter. So I can complete the initial command, which is ping and then whatever I am inputting. So I'm going to add a semicolon there and then attach my own command to it. And in this case, we're going to get the contents of the password file. So we're going to ping 4.2.2.1 again, and then tack on another command. So what we're going to get back is the ping, and then that's the contents of the password file. So this is on a Linux system. Windows systems have different delimiters, so you'll kind of need to understand which operating system you're working with in terms of what commands you can run. But that's generally pretty easy to do. You can get it maybe figured out from the headers that you're getting back from the server, and we'll talk about how to get headers back a little bit later on. But when you're doing command injection, remember that you're attacking the operating system, typically of either the web server or the application server, depending on which of the two is handling that particular request. So you're going to be sending in operating system commands. And again, this all comes down to the web server or the application is not properly validating the input that it's getting, and it's not noticing that, oh, by the way, there's a semicolon there and it's trying to send in another command. So these are the types of things that you need to identify so that your application developers or the company that you're working with for the particular product that you're using are really nailing down the input values that they get. So we're going to take a look at another type of web application attack, and this one is a cross-site request forgery. So this one can be a little bit difficult to understand. In some cases, it looks a little bit like what we were talking about with cross-site scripting, where you've kind of got a couple of different pathways that you're using. But the difference here is, so let's just take a look at what we've got. So the difference is that what I'm doing is I am crafting a particular URL that I really want somebody else to click on. So we did kind of the same thing with cross-site scripting, but in this case, what I'm really doing is I want another user to go to a particular page on another server. So we'll just plug in an admin. So I'm going to change my password. So what I'm going to see here is the URL. And when I've got this URL, what I can do is I can copy this out. And then what I can do is I can do something like, we're going to edit an HTML page. So I've got a bunch of stuff. So we've got HTML, for example, and then we've got body. So now I'm going to create an image tag where my source is going to be what we just did there. And then I can add additional parameters here to make sure that it doesn't display, but what's going to happen is I'm going to send this page to somebody and get them to come visit it, and what's going to happen when the page loads is it's going to hit this image tag, and it's going to generate a GET request to whatever I have put into the source. The browser doesn't care that it's not an image. It's just sending out a GET request blindly based on whatever this says. And so what's going to happen is, in this case, I'm going to be getting somebody else to send this request to, in my case, 192.168.2.138 with a password change. Since I have crafted the password change, I now know what their password is. So this is a pretty dangerous type of attack where an attacker can get an unsuspecting user to do a wide variety of things if the server isn't paying attention to what's happening. So what should be happening here is the client should be sending a post if it wants to do something that's making a change rather than a GET. That would render this just completely moot. So we would not be able to do this attack if the server was paying attention to the method that it was getting, since something like this should never be done using a GET request. It should be done using a post. So that's one way of mitigating this particular vulnerability. Now, a lot of times, servers with web applications these days are starting to use XML more and more. And so there's asynchronous Java and XML, or AJAX, and they're transmitting information back and forth with XML. So there are XML attacks now that have the potential to, let's say, run programs on your system. So we want to protect against XML attacks. And we're going to take a little bit of a look here at an injection attack that's associated with XML. And this isn't the only type of XML attack, but this is one of them. So what we've got is the ability to do XML-based queries in some cases, and these are called XPath queries. So you are using the XML and querying against it. So this is sort of the same sort of thing as an SQL injection attack, where you can send a query into the server in the end. Now, we're going to just hop over to the OWASP page that talks about XPath injection, and you can see this is an example vulnerability here where the XML script or the XML code is there where all of the data is stored, and then we've got a couple of different ways of triggering this type of injection, where you can do things like A equals A and password equals whatever the password is. So you can do, again, the same sorts of things that you can do with SQL injection attacks. Now, the thing about this is I was playing with this last night and have been playing with this previously, and this I think is one of the incomplete things with XVWA at the moment, because I wasn't able to get anything other than a blank page no matter what I did with this page. Even when I did something that should have been legitimate, I just got a blank page back. So that's another type of attack, and eventually I think this will be something that you can use to really play with your XPath injection queries and attacks, and that's not DVWA but XVWA. But at the moment, it's not something that I can use to demonstrate. But again, it really comes down to being able to do query strings similar to the SQL queries that we were doing when we were doing SQL injection. Typically, when web applications are getting data, they are making sure that they are encrypting the data. And more these days, even just regular communication with a server is starting to get the server to make sure that we're always doing HTTPS, which is HTTP secure. So we're doing encryption over even just going to Apple's or Microsoft's page, or even just visiting Google for the first time. They are just switching you to encryption right out of the gate. However, there are still some servers out there that are using what we call weak encryption. And so let's just take a look at the type of encryption that we are doing. So these days, what you're going to see, just as we're seeing down here, is we are using TLS, which is the protocol that includes a number of other types of encryption underneath it. So we've got keying mechanisms, and we've got encryption ciphers, and we've also got hashing algorithms that we use. TLS is the most recent iteration of this type of encryption. If you are seeing a website that is still using SSL, then that is considered weak encryption because SSL is considered breakable. Now, what we're looking at here is we're doing 128-bit keys with our encryption, and we're using AES that you can see. So AES is the Advanced Encryption Standard. There are other types of encryptions. So for example, triple DES or 3DES, you might see that's weak encryption. DES is weak encryption. There are a number of others that you might run into, hopefully not, but you might run into that are weak encryption. So if you're seeing SSL, if you're seeing triple DES, if you are seeing small key lengths here when you start looking at the details of the encryption for the site that you're working with, that's weak encryption. A lot of it has been broken, which means we can change it into plain text from the ciphertext that we are looking at. And if I can get plain text out of ciphertext, you may as well just be sending it in plain text to begin with. So when you're working with servers, you need to be checking what their encryption values are, and we'll take a look at a tool a little bit later on that will do kind of an entire run through of all of the different ciphers that servers will support. But if you run into a case where, let's say, the browser is telling you, because a lot of browsers these days are good at saying, oh my gosh, this isn't so good, particularly Chrome is really good at locking you out of places if these older encryption mechanisms are being used. If you run into that, though, and you're working with a company, make sure you let them know you really need to upgrade your encryption, because what you're really doing is you're effectively sending plain text, because an attacker could get hold of the ciphertext and then decrypt it and read whatever was being transmitted. A lot of web applications actually have the users authenticate, and there are many reasons for that. So if we're on a company intranet, for example, you want to make sure that only people who are with the company are viewing the data. So if there's any sort of sensitive information, you're commonly being asked to authenticate. So there are a number of problems with doing weak authentication. So one of them is just how we handle the authentication to begin with. And so if we were to go into trying to log into a web page, we might have an issue where we had, for example, not having password policies or transmitting logins in the clear. Or you may have an issue with session flaws. So in some cases, what I can do is I might be able to grab a session ID from you, and there are a number of issues with potential session IDs where in some cases I can grab a session ID, and I've been able to do this with web applications in the past. I've been able to grab a session ID from one browser, copy it over to another browser, and use it to log in as the first user without ever including any credentials. So when we are looking at HTTP headers that we'll look at a little bit later on, you'll see that the session ID is being transmitted back and forth, and that's one way that we can do weak authentication. You also may want to think about how you're doing the interaction with the user. There are some types of forms-based authentication, or even if you're doing HTTP authentication, then an attacker can find it much easier to interact with your web application to do brute force attacks. So doing things like changing your username and password from being on the same page to being on separate pages may be another thing that you want to think about doing. So there are really a lot of different ways of doing authentication, and also a lot of ways to do authentication poorly. Making sure that you have locked down your session IDs so they are specific to a particular system and browser is important. Making sure that it's not really easy to just brute force password attacks. Making sure that you're not vulnerable to SQL injection is another good one. So there are a lot of things that you want to be thinking about as you're working with a company on making sure that their authentication mechanisms aren't weak. Often when you are doing some sort of application attack, you can end up getting error messages. And so we can take a look at different error messages. Like, for example, a 501 is an error message. 500 is another error message. What you don't want to do when you've got error messages is you don't want to give away too much detail. And this can definitely happen when you are doing application attacks. And certainly you don't want to provide details about, let's say, the database and the version number. So you don't want to provide details like that. And you don't want to provide things like the web server information. So we're going to take a look at something a little bit later on called Google hacking. In the meantime, though, we can take a look at the Google hacking database, which provides some ways of looking at error messages for examples. So we can do specific Google searches for error messages, so we can get a look at what some of these error messages might look like. So this one, for example, is you have an error in your SQL syntax. So we can do some searches for that and see real pages that generate these errors. So this is a really good one. So this is actually telling us what the query that's being executed is. And so this is a really bad error message. This is the kind of thing that should never be presented to the user. You might generate just a 500 message or something saying, oops, we did this wrong and this shouldn't be happening, but to just spit out the entire response from the database server or even the application server is a really bad thing. So now I know details about their database. So I know there is a table that is called school details, and I know there is a field in that table called school ID. So I've got details about their database structure now, and that's one of the great things about error messages, is that we can start getting better ideas about how the application is handling things and also the structure of the database just by looking at these error messages. As we're doing web application testing, you're going to be working with a number of tools. So some of these are going to be proxy based, which means we're going to be sending requests from our browser into this proxy so that the proxy sits in the middle and can analyze the request and the response for different vulnerabilities, and it gives the proxy tester, whether it's Z-Attack proxy or Burp Suite or whatever the particular proxy that we're using is, the ability to manipulate the messages that are being sent through it and also make sure that it sees both ends of the communication. So when we do things like that, we need to go and make sure that our browser is configured to use a proxy. So I am using Firefox here, but this will work on any browser that you are working with. And in Firefox, I go to Preferences. With Chrome, you're going to be doing something a little bit different. You may go to Settings, for example. And again, in Firefox, I'm going to go to Advanced. And then when you get to Advanced, it will commonly come up with General, but I've been doing this a bunch, and so Firefox already kind of knows where I'm going, so it dropped me into Network just because that was the last place I had been. So when I get to Network, I can now click Settings. So this is where you configure the proxy, and this dialog box here will look almost identical regardless of the browser that you are using. It's going to have a setting for no proxy. You're going to be able to auto-detect proxy settings. So there may be a server on the network that provides proxy settings to clients, so they know whenever they connect that this is the proxy server that they're going to be using. What I am going to be doing, because I generally don't want to do this across my entire system, because sometimes I want a browser that can just get directly to the internet without clogging up the list of sites that I've been visiting in the proxy that I'm using. So I don't want to use system proxy settings. I want to do a manual proxy configuration. Generally, you're going to be setting it to your local host or 127.0.0.1, and then the port in the last case that I did was port 8080. You may have something like port 8008 or whatever your proxy is telling you. So Z-Attack proxy will have a configuration for the port it's listening on. You can use the default or you can change it, whatever you want, but look for the default proxy setting or whatever the proxy setting is for Z-Attack proxy, Burp Suite, or whatever tool you're using, and make sure you plug that in there. Also make sure that you use this proxy server for all protocols, just because you may be asked to go to an HTTPS server, for example. And if we're not using the proxy for those things, we're not going to be able to see those messages. So just simply use this proxy server for all protocols. You can certainly get into changing for the different protocols if you want. The simplest thing is generally just use this proxy server for all protocols. But this is how you would configure your browser to be able to use the proxy server that you want to be able to use. Now, one thing that a proxy gives us the ability to do is it gives us the ability to manipulate requests and responses that are being sent back and forth between the browser and the server. However, there is another program or another plugin that we can use within the browser to be able to manipulate those requests as well. So this is something that I have installed, and if you need to install these plugins, what you would do would be to go to add-ons in your browser or extensions, whichever browser it is you're using. And some of the plugins that we're going to be looking at are going to work in one versus the other. Some will work across both. I find that Firefox often has a really good set of plugins that are available because the other browsers are generally more locked down than Firefox is, and Firefox gives the plugins more leeway to do things. So we're going to take a look at this plugin here called TamperData. What TamperData does is it grabs the request before it has been sent out. And so we can just go to something that we've gone to before. Let's say we're going to go to the damn vulnerable web application. And what I can do is go back to TamperData, and you'll see the requests that are showing up here. So if I click on one, you can see the request down at the bottom and the response. Now, the interesting thing that I can do here is if I click on Start Tamper, what it's going to do is it's going to grab and intercept the request and not send it off until I have done what I want to do. And so if I click on this, TamperData is going to pop up a message saying, hey, guess what? I just got a request. Do you want to play with it? So I could submit it if I didn't want to tamper with it. What I want to do, though, is I'm going to tamper with it. So I can make changes to all of the headers. And I can also add parameter names. So I can say, for example, and now suddenly I am sending a post parameter. If I have sent a post request in, those post parameters will show up on the right-hand side. I can manipulate them after the browser is done with it. So what this gives us the ability to do is not only very quickly grab these requests and see them rather than using an external tool, I'm just using a plugin in the browser, but it also gives us the ability to bypass any JavaScript validation that is part of the page. So there may be some code in the page that is doing validation, and then it's sending it off to the server. Where the best place to do it is you can do it in the browser, but you also want to do it on the server end rather than assuming that the JavaScript is going to work 100% of the time. Because if I can grab this using TamperData or any other proxy and manipulate it after the JavaScript has said it's okay, I can then fix it back to something like a SQL injection attack or a cross-site scripting that the JavaScript was saying, oh, we can't do that. So I now have a way of grabbing messages in the browser and making manipulations to them that maybe the page is trying to prevent me from doing. We're going to take a look at another plugin that is called Firebug. And Firebug is not only valuable for us as testers, it's actually really valuable for anybody doing web development. So what we get when we open up Firebug is we get the ability to do inspection of a page. So I can mouse over any of these lines here and it will show me exactly on the page what that line is referring to. So now I've got an element here in my division that is the main menu. And so when I mouse over that, you can see that at the top it gets highlighted. So I can really do some inspection, and you can see over on the right hand side we've got the cascading style sheet details for all of the rules that are in place. So we've also got a way to look at the debugger, so we can look at the sources. There's JavaScript that was included in the page. Now I can look at the JavaScript that's there. We can look at a call stack, meaning there were different functions that were called. In this case, there's nothing. I can start making changes to the style sheet that was provided. So I could change the color, for example, here. So I can do a lot of different things in manipulating the page even after it's been presented to me by the server. So Firebug, again, is a really useful tool for web developers, but also it gives us some insight into the elements of the page so we can get a better understanding of where there may be code that we can start manipulating in some way or another. So Firebug is a great plugin that you can have installed within your Firefox web browser. Now I've switched over to using Chromium, which is the open source version of Chrome. You can install Chromium in Kali Linux and get the Chrome experience. Just it's going to have a different icon, but other than that it's going to behave just like Chrome does. As I said, Chromium is just the open source version of Chrome. So the reason I've switched over is because there are some plugins that only work in Firefox, some that only work in Chrome. This happens to be one that only works in Chrome. And so I'm going to go to Request Maker, and what I can do is I can go off to a page, and we'll just grab something here where I've been before. And I can start doing things like, let me just grab this URL. Now I can start generating the messages that I want to send, and I can switch the type of request that I'm sending. So I could do a put, I could do a get. So if I were to do a get there, for example, then I can look at the response headers and you can see what I've gotten for a response. So using Request Maker, I can start creating a request that looks exactly like I want it to look. So I can start adding header values in. Now, when I generate this request, it's going to have that header that I'm sending in to the server. And some servers may not be able to handle headers in a particular way, or you may be able to craft a header that's got a session ID in it that you particularly want to use. So you can use Request Maker, this plugin, to be able to create exactly the type of request that you want with all of the headers that you want, and then be able to look at the response that's coming back. So I can look at the response headers, and I can also look at the source code that comes back as well. So this is a really useful little utility if you want to be able to craft your own messages that are being sent into a web server. You can certainly use Request Maker. And again, this is a plugin that will only work in Chrome, or in our case, Chromium. When we're doing web application testing, you really need an entire set of all of the pages on a website. So when you're testing an application, you need to get the complete set of pages, and then you can start weeding out ones that you're going to be able to test. So static pages you're not going to do anything with. Really the only avenues into an application are going to be where there are programmatic elements. And so there are generally going to be a bunch of them, but in order to figure out where I'm going, I need to get the roadmap essentially, right? So what I can use is a plugin called SiteSpider. And so I'm going to use that. Again, I'm in Chromium because this is a plugin that works in Chrome and doesn't work in Firefox. So I can use this to just generate a spider of all of the pages. And we call it a spider because it is going through the web. So we're getting all of the pages from a website. So now I'm going to say start on this page and make sure that we restrict only to things that look just like this. So we may have links to other sites. We're not going to spider those because the next thing you know, we've got every site in the world that we have spidered, and that's just not very useful for us. So I can follow one link beyond restriction if I want, check inline content and so forth. In this case, I'm just going to say go, and then SiteSpider is going to present us with a list of all of the pages in the website that we are working on testing. And as I said earlier, you can certainly use other tools for doing this if you're doing just vulnerability assessment with web applications. You may be using ZAttack Proxy or Burp Suite or something like that. Those will do a spider of the site as well. But if you want to do some manual things, you can use SiteSpider to be able to get you an entire list without having to go to that other application. You can just use the plugin inside the browser. We're going to take a look at another plugin, and I have switched back to Firefox now to look at something called HTTP Header Live. So I'm going to open that up, and then what I can do is I can click on something, and what you'll see is we can now see all of the headers that were generated by clicking on that page. So what I can now do is, first of all, I can save all of these off, but I can also, if I were to just click on one of them, it is going to open it up in a separate window. And then what I can do is I can start manipulating this. And I can make changes here. And then what I can do is I can replay the send. And then it runs it through the browser, and you can see that what we've got here is just that individual component from this particular request that we were sending that's now been rendered back in the browser for us. So we can do anything that has been sent once we've opened up these live ones. We can just start making changes to these and then replay the send back. So that gives us the ability to do a lot of verification of requests. So if you are doing web application testing, maybe you've got an automated tool, it has told you that there is something that is possible, and it may be really hard to do that by just interacting directly with the browser. This may give us the ability to do some manipulations, like, for example, changing the method, or you can change the headers that are being sent off. So we've got another way of doing essentially manual interaction with the web server to see if we can trigger a vulnerability. We're going to take a look at another toolbar. So this is a plugin, but it presents me with a toolbar that I can use. So let me just bring that up. If I go to View and Toolbars, I can do Hackbar. So what Hackbar does is it really gives us the ability to do some things very quickly. So for example, I could do a base 64 encode. So I could type some value here, and then I could do a base 64 encode. And what it does is it converts what I had plugged in into base 64. So now if I were to select that again, I can do a base 64 decode. I can also do things like URL encoding. So URL encoding is where we convert special characters, so for example, a space, to the hex value of its ASCII code. So if I were to do that, we would see %20 show up, and 20 is actually 32 in decimal, 32 in ASCII is the space character. So stupid pet tricks, right? You can tell somebody you can do a little quick conversion of hexadecimal to decimal and say, look, 20 is 32, congratulations. So we've got a number of different manipulations that we can do without having to go off to another website. So often if you do base 64 encoding, what happens is I got to go to another website or I've got to get another tool. Here I don't have to leave the browser. I can stay exactly where I am and do some cross-site scripting things, so I can look at HTML characters, I can generate an alert statement here, and again I can do the encoding and decoding, as well as we can get MD5 hashes and SHA-1 hashes. So Hackbar is just a really good utility to have around if you need to start manipulating and massaging data, particularly if you need to get hashes or do some encoding or decoding. It's just a really good thing to have around, so you're not having to jump off to other tools or other sites. You can just stay exactly where you are, pop open the Hackbar toolbar, and you can do everything that you want from right inside the browser, staying in the page that you're at. So another plugin that we can use, and again I'm back to Chromium here, is we can use the plugin Bug Magnet. So I can use Bug Magnet to do exploratory testing, for example. So you can see this is their page. If I go to my options, I can see that we've got the ability to add a configuration file that we're not going to do. But what I can do is go over here, and then I've got the Bug Magnet menu pops up if I go to something that's essentially a programmatic element. So in this case, I've got an edit box. I right click in the edit box and I've got Bug Magnet that shows up, and what that gives me is some abilities to do things like doing characters, for example, that are difficult to type. Or I can go to Bug Magnet again, and I can just start plugging in numbers. I can add invalid URLs, for example. I can plug in numbers. So it really just gives me the ability to do shortcuts that may potentially break the application. So I could generate a bad MasterCard credit card number there and plug that in. So it really is helpful for just generating potentially bad data to start plugging into the web application. So as we're doing our testing, we can do things like validation testing, and we can do boundary checking just very quickly by doing this, plugging data in using Bug Magnet from menus rather than having to type a lot of data, particularly in cases where some things are just simply hard to type, where you've got special characters, for example. Websites generally use chunks of data that are called cookies, and you may be familiar with cookies already. So if I need to get into an application multiple times, probably the server is going to drop a piece of data so it knows that I have visited that server before. One of the challenges with HTTP is that it is entirely stateless. So the protocol has no idea whether I have been in communication with it before, every request is self-contained. So as a result, we've got cookies that we can then use to save the data and in part to give us the ability to maintain some state. Now, when you're doing testing, what you might need to do is be able to manipulate those cookies. And so there are plugins that we can use to be able to view the cookies and manipulate the cookies and so forth and copy them out. So this particular one that I'm looking at now is called Edit This Cookie, and I'm in Chromium. This is a plugin that works in Chromium. Firefox has a whole bunch of cookie editors and cookie viewers that you can get, and frankly Chrome does as well. I just grabbed a couple that I have used in the past. So we've got our cookie editor where I can start changing the values of the cookie, and then I can change the path, for example. So I can make changes to the cookies that are used on this particular page. Now I can also take a look at a cookie manager, and what the cookie manager is going to do is not just show me the cookies that are on this particular page, it's going to show me the cookies that I have stored all over the place. So any cookie that I have stored, I am going to see in this list of cookies. So now what I can do is I can start selecting these domains, and I could save them, I could delete them. So in this case, I'm going to delete those cookies, and I'm going to delete the ones that are associated with Edit This Cookie as well. So I can just start deleting cookies using the cookie manager. I can also, of course, see them by just looking at the cookie details when I click on them. So as I said, there are a number of plugins that are cookie related that you can use, and these are a couple, as I said, that I've used. And you can use Edit This Cookie for particular cookies. You can also use cookie managers to be able to go outside of the context of an individual page and see all of the cookies that are on your site. Now we're going to look at a plugin that doesn't do anything itself particularly, but what it does do is it gives us the ability to add in more functionality. So this was something that goes many, many years back that really allowed people to manipulate and customize their browser before there were a lot of plugins. So we're going to take a look at GreaseMonkey. And what GreaseMonkey does is it gives us the ability to add scripts in that will customize the browser, make changes to pages. So there are really a large number of user scripts that are available, and you could go to openuserjs.org, for example, and see the different user scripts that are available that you can add via GreaseMonkey. So for example, there are some user scripts that are available here on this GitHub page. But what GreaseMonkey does is it just gives us the ability to run these little scriptlets, if you will, to be able to make very quick and simple changes to a browser. And you can just add up these scripts to make the kinds of changes that you need to make based on whatever it is you're trying to do, whether you're customizing or there are some cases where you can interact with the page and so forth. So GreaseMonkey is kind of a general purpose plugin that gives you the ability to add additional functionality using these user scripts. When I am communicating with a web server, I'm sending a bunch of data to it. So I'm sending a request like a GET or a POST. I'm also sending a bunch of headers. So there's a date header, for example. There's also commonly a user agent header, and that tells the web server the type of browser that I am running. So in this case, I am running Firefox on a Linux system. If I want to masquerade as something else though, I can use User Agent Switcher, which is a plugin, and what I can then do is I can select different devices. So I could be a Tizen OS device, or I could be a Nokia Symbian device, or I could be even Firefox OS if I wanted to. So I can select Android, I could say Opera, and then the operating system, let's say we're going to be using Mac OS. So I could change that, and you'll notice that when I go down to operating system, of course, it undoes all of those because now I've got to change the operating system. Obviously, I can't have Android and also Linux because they're really two different operating systems. So I can make changes to the browser and tell the server that I am using Microsoft Edge, for example. And I can change it to different operating systems. Now what you'll see is it's doing a little bit of sanity checking. I selected Edge and it automatically selected Windows for me. And I can't go over here and select FreeBSD because Edge doesn't exist on FreeBSD. So I do have the ability to change the user agent field that's being sent off to the server, because sometimes pages will render differently depending on the browser that they're in. So if you want to do testing that is based on, for example, using Microsoft Edge or maybe Mozilla's Firefox, but you're using a different browser, you can use the user agent switcher to tell the server that you're something different so that it behaves differently when it comes back to you. When you're doing testing of web applications, there are a number of technologies that you're going to be interacting with. So there's the web server, there's also the application server. There may be a number of frameworks that the application server is using. So a really quick way of getting the list of all of the technologies that are in place so that you know what you're dealing with and maybe get a leg up in terms of potential vulnerabilities that you can test for is you can use a plugin like Wapalizer, and I'm in Chromium, or you could use Chrome, of course. If you are on Windows or Mac OS, you can use Chrome there. So I'm going to use Wapalizer to give me a list of the different technologies that are in use on the page that I am looking at right here. So we can see that they are using the jQuery JavaScript framework. They're using an Apache 2.4.29 web server. I shouldn't say they because it's really me. I'm running it locally. And we're using a Bootstrap web framework, and the operating system is Debian. So if I were to go to, for example, apple.com, and I go off to my Wapalizer again, what you'll see is that the icon has changed because the details have changed. So what they're using is Apache, and they're also using Site Catalyst. So what we got for an application icon at this point is the one for Apache. So if you need to very quickly determine all of the different technologies that are being used on a website, you can use Wapalizer. So in the case of Google, they're just using the Google web server, and you can do this on any page, and Wapalizer will quickly tell you technologies that it has found within the interaction with the server or in the page itself. So another utility that we can use in order to get details about the different technologies in place is something called page X-ray. So if I go to any page, and go to this page here, and then I right click with the plugin installed, and here I'm on Chromium again, I can select Scan with Page X-ray. And so what Page X-ray is going to do is it's going to, at the bottom, show me the different technologies, and once I have identified some technologies, if I just click on the icon, it will take me off to give me details about what it has found. So it found jQuery, for example. So we're off at pagexray.com, and it is providing me details about that particular technology. So what I have noticed between Page X-ray and Wapalizer is Page X-ray is identifying some different technologies, or fewer technologies rather, than Wapalizer was. In this case, we've only got 2 from Page X-ray, where Wapalizer actually gave us a total of 4. So what we got from Page X-ray was jQuery and Bootstrap. So it's really talking about kind of the frameworks that are being used. So there's a web framework here and a JavaScript framework, where Wapalizer will go all the way down to the OS if it can do that. So this is another plugin that is useful. One advantage that we've got to Page X-ray is if you click on the little icon, again, it will take you to a page at pagexray.com, giving you additional details about the technology that's being used. We've been talking a lot about headers so far, and there's another plugin that we can use to modify headers. And so I'm going to use this Modify Headers plugin in my Chromium browser. And what this gives me the ability to do is just add some additional headers that I want. So I've got profiles. I've got profile 1. If I wanted to create another profile, I could add an additional profile, and I can also just start adding request headers and making changes to them based on, again, trying to manipulate the server in a particular way, so I can add headers in that will give us the potential ability to modify the way that the application works. So I can add headers that maybe trigger an application to crash, for example. So this is another way that I can add in headers that I'm going to send off to the server. And again, this is the plugin Modify Headers that I am running in the Chromium web browser. When you're working with a number of web scanners, often you're working with tools that are going to behave as proxies, and sometimes they're going to use different ports to listen on. So you could go through and just make the changes in your browser by going into settings, or you could use a tool like a proxy switcher. So what I've got here are a couple of profile settings. So I've got local proxy, for example, where I can change to the proxy settings of using a proxy at 127.0.0.1:8080. If I had another proxy that I used a lot that was at, say, port 8008, I could add that in as well. So I can very quickly change my proxy settings and just click on a button rather than going through the steps of getting to settings, finding the proxy settings, making the changes, applying them. What I can do with this is just click on my proxy and make the changes there. If I need to add additional profiles, let's say I want to change this to be 8008, and I'm going to say 127.0.0.1 port 8008, and I'm going to use that same proxy everywhere. Now I have a third proxy profile, and As soon as I click up here, it shows up. So this is a time saver. Rather than going into settings and switching things around, I can just very quickly move from one proxy to another and then back to using no proxy. So encryption is a really important component to a lot of web applications. And you want to make sure that whoever you are working with is using strong encryptions. So we've got a program that I'm going to take a look at here that is the SSL scanner. And what an SSL scan is going to do is it's going to initiate a handshake with whatever server we are testing in order to determine the different encryption ciphers that that server supports. So there's nothing in doing this that is dangerous in any way. It is just the normal course of interacting with the server. The server is going to give us the capabilities that it has. All SSL scan is going to do is going to provide that list to us. So we can use SSL scan to do testing against any website. So we can figure out what encryption ciphers Microsoft is using, for example. So now we've got the list of all of the encryption ciphers. One advantage to using something like SSL scan is it will easily detect whether the server that you're communicating with is vulnerable to Heartbleed, which was a vulnerability from a few years ago with the encryption process. Most servers have been repaired by this point, but you might run across a case where it's not. So in this case, what we are looking at is we are looking at a server that supports TLS version 1.2, 1.1, and 1.0. 1.0 may be a little questionable at this point, but there are still people using browsers that don't support the latest versions of TLS. And so you'll still see cases where web servers will support older technology just because they have to deal with clients who are using older technology. So what we are looking at, though, is a set of encryption ciphers. So we've got the key exchange mechanism, and then we've got the way that we are doing public and private key encryption, and then we've got the symmetric key encryption. In this case, it's AES. Their preferred is going to be AES with a 256-bit key, and then they are using SHA-384 to do their hashing. So these are all really good for the most part. Again, they're having to support TLS version 1.0 to support some older technology they've got. So we can get a list of all of the encryption ciphers and server ciphers that are supported by the system that we are testing just using SSL scan. So when you're doing testing, as I've mentioned before, you really need to do some validation. So we're going to be talking a little bit about sanity checking. If you need to interact with a server in a way that is outside of using a program so you have entire control over what you are sending, you can use a couple of tools. So the first one is the Telnet client. And the Telnet client, while default use is to connect to a Telnet server, it's also a great utility to just open up a TCP socket to some server somewhere. So I can connect to the web server port using Telnet, and then I can start sending HTTP messages off to the server. So what I have just told the server is I want to do a GET request on the top level page, and we're going to use HTTP version 1.1. Since I'm using version 1.1, I also need to provide a host line because HTTP version 1.1 supports what we call virtual servers. So I can have multiple servers that are being hosted up at the same IP address. That wasn't the case with HTTP version 1.0, and so I can then send that message off, and what happened was I was talking and it timed out on me. So let's try this again, and I'll do it a little bit faster just so you can see the response coming back. So when I'm sending this off, I can send one blank line. I have to send a second line, or rather one complete blank line. So I do a carriage return on the host field, and then I send a blank line, and then the server goes, okay, now I know you're done. So then it sends the response back. So I can use Telnet. I can also use Netcat in the same way, where I can say localhost, and then I can communicate over port 80 and use Netcat to do the same thing. Now, you may run into the case where you are using encryption. So Telnet and Netcat won't work for any server that is using encryption, and so we would use OpenSSL and the S client, which is their encrypted client, to communicate with the server. So it's SSL, TLS. Even though it's called OpenSSL, it still is TLS underneath. So we can say OpenSSL and then connect. Let's just say google.com:443. So now I have just opened up a connection to Google, and so I can do the same thing. And again, it timed out on me, so it just very quickly sent something back because I wasn't typing fast enough. But if you need to communicate with an SSL server, you can use OpenSSL and the S client to get you connected so that you can start sending messages back and forth to the server. And in the case of the S client, we've got all of the details from the certificate and the encryption that is being used that we can also investigate. So if you need to manually interact with servers, you can use the Telnet client, you can use Netcat, or if you need to do encryption, you can use OpenSSL's S client. Now that we know how to interact with servers, let's take a look more closely at the response that we get back. So I'm going to communicate with my local host on port 80, and I'm going to send a GET request again, and I'm going to say host is localhost, and then I send my blank line. Now what I've got is all of the HTML there, but I'm going to scroll all the way up to get to the headers that were being sent, just so we can look at what we're getting back. So the very top line that we're getting back is the response code. So HTTP uses numeric response codes. Anything in the 200 line is going to be some probably success message of some sort. 200 OK is the common one that you will see. Anything in the 300 line is going to be some sort of redirection, and 100 is going to be informational. If you get 500, that's a whole bunch of server error messages. So you might see 500 or 501, for example. So in this case, we got a successful request, so 200 OK. We get the date back, and then the next line is the server, and this is where you might want to look. So in this case, it's not only an Apache server, it's an Apache server version 2.4.29, and it's saying that it's running on Debian. The reason it's saying it's running on Debian, even though we're running Kali, is because Kali inherits from Ubuntu, which inherits from Debian. So ultimately, it's a Debian-based system. So we're also getting last modified headers, we're getting content length, and content type. So this is a MIME type there, and MIME type stands for multi-part internet mail extensions, just so that we can differentiate between content types. So this is just text HTML, and that's going to be a common MIME type that you're going to see. So reading through these headers is a useful thing to be able to do. They are all going to be in English. Sometimes you will see more headers here depending on the application that you're using. This is a very simple set of headers that we are using to communicate with other servers. Particularly if you're using a web application, you'll get a whole bunch of additional headers where they're sending cookies and they're maintaining data and session IDs and so forth. So being able to read through these headers is often a helpful thing for you to be able to do. So you want to do this manual interaction with the server so you can really clearly see what header was coming back. Now, I'm going to move away from using tools in this case that are on Kali, and I'm going to move to looking at a website. So there are a number of websites that you can look at that will give you some details about vulnerabilities. Since we're talking about web vulnerabilities, this is one that limits itself to web vulnerabilities, and this is related to cross-site scripting attacks. So this is xssed.com, and you can see if you want to keep track of latest cross-site scripting attacks and vulnerabilities, this is a good page to go to. So you're looking at news articles about a cross-site scripting attack. And so you can see that there was a vulnerability found on eBay. So there's a page here that he injected cross-site scripting to, and of course, not surprisingly, eBay has removed that particular listing. But if you want to learn a little bit more about cross-site scripting attacks, you can certainly go to XSSED and look at the archive and be able to see domains that have been vulnerable and get details about the different cross-site scripting attacks that have been successful in the past, so you can start building up your toolkit for different ways of running these cross-site scripting attacks. What often happens is that web applications have found particular ways of doing validation testing, and then attackers go in and find more ways of getting around either intrusion detection systems or web application firewalls maybe, or some other self-protection mechanism. And so you can learn more about ways of doing this evasion and being able to get attacks through by looking at successful attacks, and you can do that here at xssed.com. Invariably, when you're doing any sort of testing or just in generally in life, you probably are going to have to Google something. Now, when you Google something, like for example, I go and look for cross-site scripting, I get a large number of responses back, and in this case it looks like over 2.5 million responses I was able to get back here. So there are ways to narrow the results down, so that process is called Google hacking. And what Google has done is provided a number of keywords that allow us to really narrow in what we are looking for. So for example, I can say site and let's say sans.org, and now I'm going to look for cross-site scripting. And what I'm going to get back are only results that are at sans.org. So you can see sans.org, the reading room. In this case, it's software-security.sans.org. So I'm limiting myself to a particular domain by using that site keyword. And I went down from 2.5 million to about 2,300 results. So that's a much more manageable type of response that we've gotten back. So another thing that I can do is I can look for particular file types. And let's say I want to look for PDFs that reference cross-site scripting. I can use file type :PDF and then do my search string, and now all I've got are PDFs that reference cross-site scripting. I can do the same thing with something like docx, for example. So that's a Microsoft Word document. So I can do file type. I can also do in URL. So this case, all I am looking for is something that exists in the URL. So this right here is the URL. That's the thing that shows up in the address bar. If I want to look for a particular string that shows up in the URL, then I'm going to use the in URL keyword. I can also use in text if I don't want to look through headers or the URL value. I can specify in text. So there are a bunch of keywords that can really help you get down to a reasonable number of responses that are very targeted and very focused for exactly what you are looking for. Or vulnerability data. So here are some search strings that you may want to look for. Now, Google hacks are sometimes called Google dorks, and that's actually the search string